Hello everybody, my name is Kees and I work at the Deltares, a research institute in the Netherlands. And today I'd like to present you some of our research on sand engines to tackle riverbed erosion in the Rhine Meuse Delta. Sand engines, the topic of this talk, are considered nature-based solutions, but for what and why? So let us focus on river topics. So we can find in rivers some river reaches might erode because there's a lack of sediment supply, maybe combined with some high flow dynamics. In other reaches, we can see some sedimentation because of an excess of sediment supply. So when we bring these two together, we can actually dredge the excess sediment and nourish it back to the eroding sections. So this is the topic of the sand engines. Sand engines we create by nourishing a large volume of sediment at one place and let the flow spread it over the eroding reach. So some examples are shown below here. The sand engine at the left is the big coastal practice project, and there's another one on the right where you can see a smaller sand engine in the new Waterweg, which is a river in the Rhine Meuse Delta. So let me take you to the Rhine Meuse Delta, which is in the western part of the Netherlands, as shown below on the map. It's the delta of the rivers Rhine and Meuse. Due to all kinds of anthropogenic effects like the estuary closure and several river training projects, we have actually caused erosion of several of the river branches in this delta. While these river branches are eroding, they are cutting into a highly variable geology, the former deltaic deposits. And that's causing more than about 100 deep scour holes in this region. This picture shows an example of such a deep scour hole in one of the branches. You can see on the left, you can see the sandy area that's a former creek, which is actually eroded rapidly. On the right, you can see erosion-resistant clay and peat layers resisting erosion. So there's a large issue about this, because these scour holes are located next to levees and apartment buildings, as can be seen in this picture. The depths of this scour hole are more than 20 meters, so they are a safety problem, a flood safety problem for this area. Instead of filling up scour holes and protecting them with riprap or stones, we actually are looking for more sustainable and more flexible solutions, which are more nature-based. So in this example, in this pilot, we are looking for a solution in nourishment of sand into these scour holes to create sand engines. So the pilot site indicated in this picture is actually located in the Old Meuse Oude Maas branch, one of the most eroding branches in this area. At the entrance of this branch, there are 3 large scour holes with depths over 20 meters, and the overall depth of the channel itself is about 10 meters. So there's a difference of about 10 meters below this. There's also some of these scour holes are located close to the embankments. So there's a reason to stabilize them. As I mentioned before, the riverbed is eroding over the entire length of the channel, but there's also these deep scour holes. So with this solution, we try to kill 2 birds with 1 stone. Actually, we want to stabilize the scour hole by filling it with sand, but we also like to stop the bed degradation of the entire channel, of the entire river. So on the left, you can see some images from a nourishment. On the right, you can see a numerical simulation with Delft3D for how the sediment is spread over the channel, through the channel, downstream after the nourishment. So does it really work like that? So actually we added about 50,000 cubic meters of sand in June 2022, and in April 2023 we did another nourishment of 11,000 cubic meters into these scour holes located in Zwijndrecht in the Old Meuse. After the completion of the nourishments, we started a huge monitoring campaign. So on the right picture, you can see a difference plot between bed levels before and after a nourishment. And you can see green is sedimentation. And on the right of this picture, you can see the scour holes where sediment was nourished. What we learned from these pictures is that the nourished sediment is slowly eroding from the scour holes and is going towards the downstream to the left as a progressive sedimentation wave. And it goes about a speed of about a few hundred meters per year, with a thickness of about several decimeters. And the driving force to this is the tidal flow. It's not really the large flows from the river, but it's mostly tidal. We could not find a lot of experience of this kind of procedures in other rivers. So this pilot was also used to learn by doing. We could see that there were some shortcomings in theoretical concepts, but we could also accept this because we know that nature is really unpredictable and complex. Just to make sure that these kind of pilots or procedures do not cause any problems, we can use safety factors. The other thing that we noticed was that beneficial use of dredge disposal is not yet part of a maintenance contract. So you have to break up these maintenance contracts to allow this kind of procedures. As we found that this solution is very successful for this river, we are now planning to continue feeding the sand engine for the coming years. I'd like to thank you very much for listening to me.